All right, this is the third video from Chapter 4, Section 2. We're still doing homework problems from page 326. All right, so I've gone to the section. This is problems 33 to 48. Had this instruction: write the polynomial as a product of linear factors and list all the zeros of the function. So that from the first video, that the function equals some number k times the product of x minus ci's, that sort of thing. All right, so let's do problem number 33. Do the first one. So we're given this information. Our function is x squared plus 36. All right, so if we recall from algebra, that x squared minus a squared is equivalent to x minus a times x plus a. We're going to use something similar to that, but there's a function like that or a formula like that for complex numbers as well. And that's if we have x squared plus a squared, this equals x plus ai times x minus ai. And if you do the FOIL on that side on the right, you should come up with that difference, the sum of those two squares. All right, so this factors, we could certainly use a quadratic as well, but we've got this little trick here, so this should be a little easier to do. So our function, here we have 6 squared, so let me just rewrite that as x squared plus 6 squared. So now 6 is our a. Our function equals x plus 6i times x minus 6i. So this is writing it as a product of linear factors. So this is the first part of what you want. List the zeros. Well, the zero for this one, so x plus 6i equals 0, which means x equals negative 6i. And this one here, we have x minus 6i equals 0. So we have x equals positive 6i, or just 6i. You don't need to write the plus. So that's how we do that one. I will scroll down and do another one. So let's do 37. So here they use so f of x squared minus, not plus, excuse me, minus 2x, there's the plus 17. Okay, so let's use the quadratic on this. So x equals negative 2, or b is negative 2, plus or minus the square root of negative 2 quantity squared minus 4 times 1 times 17, all over 2 times 1. So we're going to solve with the quadratic, and then we'll have to put that into the form that they requested. It's 2 plus or minus. Looks like we got 4 minus 68. So root 4 minus 68. And that's over 2. It's negative 64. It's 2 plus or minus. Root 64 is 8, so that's 8i over 2. Which means we have, we can pull out a 2. So that means x equals 1 plus 4i or 1 minus 4i. So these are the two solutions. Now, but again, the question wanted us to write the polynomial as a product of linear factors. So let's go back and do that. So our f of x is going to equal x minus the quantity 1 plus 4i multiplied by x minus the quantity 1 minus 4i. Because this would be C1 and this would be C2. And there you have it. Okay, so we should do one more problem. Here, let's do one with a fourth power. So number 47, we're given that the function equals x to the fourth plus 10x squared plus 9. Okay, well, we can solve this by factoring. At least we can factor once, and maybe we can factor again or use a quadratic. So this is of the form x squared plus 10x plus 9. Instead of having a square and a single, so x to the first power, we have a fourth power and a second power. So essentially, we have a fourth, a second, and a zero. So x squared times x squared gives you x to the fourth. And then the others are factors of 10 and 9. So we need two numbers to multiply to give you 9 and add up to give you 10. Well, that's just 9 and 1. Okay, so now we have two of the form that we talked about in the first problem we did. So we're going to use, let's use this formula here. All right, in this case, so in our first case, x squared plus 9, our a is 3. So I don't want to highlight. So this is going to be x plus 3i times x minus 3i. That's our first product there. Our x squared plus 9 equals that. And then the x squared plus 1 becomes x plus I, x minus I. So this is our function written as a product of complex numbers, or x minus complex number. So this one means x equals negative 3i. This one's x equals 3i. This means x equals negative I. And the last answer will be x equals I. So those are our four solutions, four complex solutions to that fourth power that we have. And as we noted from before, we knew there were going to be four because the power leading polynomial is 4 as well. And that should end this section. I don't see anything else that we need to go. I think this is the end of the suggested homework I gave you. So I will move on to the next section.